Hi children, good morning. Good morning to all of you. In the last class, we discussed about one of the periodic property, that is the electron affinity. Right children? So today we are going to discuss about one of the periodic property. It's very important periodic property, that is the electronegativity. What children? Electronegativity. Right children? See here, what is meant by electronegativity? What is meant by electronegativity? See children, in case of electronegativity, we will say the small point children. See here, suppose if we can take the one of the molecule like HCl, what children? HCl, hydrochloric acid. Compare with the hydrogen and chlorine. Chlorine having more atomic size rather than hydrogen. Right children? See here, in this particular case, suppose if we can take the one of the compound, like here hydrogen having electronic configuration 1s1. That means in the valence cell it is having one electron. Then suppose if we can take chlorine. See here, what is the electronic configuration of chlorine children? Neon 3s2 3p5. So suppose if you want to get the nearest obligation electronic configuration of argon, chlorine required 1 electron. So hydrogen also required 1 electron. Here compare with these two elements also required 1 electron. These elements also required 1 electron. So these two elements required 1 electron means how it is possible children? How it is possible? See here, chlorine required 1 electron, hydrogen required 1 electron. See here, both the atoms are required 1 electrons. It is completely impossible. Suppose hydrogen will give 1 electron to the chlorine means there is no electrons at hydrogen. If chlorine will give 1 electron to the hydrogen means there are less number of electrons are there at chlorine. So that's why there is no possibility to give the electrons either from hydrogen to chlorine or from chlorine to hydrogen. But here, what is the possibility children? Here only one possibility is there. What is the possibility means? Here hydrogen will contribute 1 electron and here chlorine will contribute 1 electron. So this is the pair of electrons. These two we have to consider as a pair of electrons. So these are the pair of electrons equally contributed by both hydrogen and chlorine. See here, then after here one of the bond will be formed between hydrogen and chlorine. So this is the pair of electrons. So these are the pair of electrons, these two. Right children? Here, if hydrogen and chlorine having equal strength means suppose if we can take hydrogen and hydrogen, both the atoms having equal strength. Nitrogen and nitrogen having equal strength. Oxygen and oxygen having equal strength. But here, hydrogen and chlorine having equal strength children? No. These two atoms having two different energies. Compare with these atoms, chlorine having more energy rather than hydrogen. That's why these are the pair of electrons are attract towards the chlorine side. That's why here when the pair of electrons attract towards the chlorine side means then hydrogen will get partially positive charge, then chlorine will get partially negative charge. Because of here these two pair of electrons are closer to the nucleus of the chlorine. That's why chlorine will get the partial negative charge on it. Now coming to what is the definition of electronegativity? Based on this concept, I will give the definition. Right children? See here, what is the definition of electronegativity means? The tendency of an element. The tendency of an element. The tendency of an element to attract the shared pair of electrons towards itself in a covalent bonded atom. covalent bonded atom. A covalent bonded atom is called as electronegativity. See children, the tendency of an element. So these are the two different elements. The tendency means nature. Tendency means nature. The tendency of an element to attract the shared pair of electrons. To attract the shared pair of electrons towards itself. This is we have to consider covalent bond. So this is we have to consider a covalent bond. That's right. We have to say that a covalent bonded atom is called as electronegativity. Is known as electronegativity. Right, children? See here, this is about definition of electronegativity. The tendency of an element to attract the shared pair of electrons towards itself in a covalent bonded atom is called as electronegativity. Right, children? See here, this is the particularly we have to consider as a bonding property. So after formation of covalent bond only we have to define the definition of electronegativity. That's why there is no units for the electronegativity. There is no units for the electronegativity because of it is the bonded property. Right, children? So this is about what is the definition of electronegativity. So here to discuss about electronegativity, there are three scales are explained about electronegativity. What are those three scales? I will explain now. Right, children? Please also listen carefully. Here, in case of electronegativity, to explain about electronegativity, there are three scientists. They are introducing there are three scales for the explaining about electronegativity. What are those three scales means? One is Pauling scale. One is Pauling scale. And the second one is Mulliken scale. Mulliken scale. And the third one is Allred-Rochow scale. Allred-Rochow scale. Okay, children. So these are the three scientists. They are explaining about electronegativity. Right, children? First, we are going to discuss about what is meant by Pauling scale. What is meant by Pauling scale? See, children, what is meant by Pauling scale means here Pauling, he was taken that there are two properties, children, based on bond energy and bond length. Based on these two properties, based on bond energy and bond length, he was explained about Pauling scale. Right, children? Suppose if we can consider the two different atoms, like suppose if we can take here one of the molecules, AA molecule. What, children? AA molecule. Suppose if we can consider the one of the molecule, that is BB molecule. What, children? BB molecule. This is the bond between atom A to atom A. This is the bond between the atom B to atom B. Right, children? It is having some bond length. It is having some bond length. Here, Pauling, he was taken based on the bond length property. Based on the bond length property, here the bond length between these two atoms means we have to take the half of the bond length. Half of the bond length. See here the energy or bond length between atom A to atom B. Atom A to atom B. Energy between, so we have to consider only energy. We have to consider the bond energy. Energy between atom A to atom B equals to here energy of atom A half of the energy of atom A and atom A plus energy of EBB. Right, children? See here, this is we have to recognize like this also. Here EAA into EBB power of 1 by 2 according to logarithms. According to the logarithms. Right, children? See here, this is the value we have to consider as a calculated value. Children, calculated value. Suppose if we can take experimental values and calculated values. Here experimental values are always more than that of calculated values. That's why here experimental values and calculated values having some difference is there. Some difference is there. That's why we have to consider here the energy between atom A to atom B means atom A to atom B equals to here EAB experimental values minus EAB calculated values. EAB experimental values minus to EAB calculated values. This is the difference we have to consider as a delta AB. What children? Delta AB. Already we know the calculated values. EAB into EBB power of 1 by 2. So then here delta AB equals to EAB experimental values minus, we have to written EAA into EBB power of 1 by 2. So this is we have to consider as a delta AB value. This is we have to consider as a delta AB value. See here, generally what I am saying here, electronegativity we are explained based on bond energy and bond property I said. See here, what are the units for bond energy here? Kilocalories and kilojoules. That's why when we are expressed in terms of CGS units and SI units. Suppose if we can take the CGS units. What are the units of CGS units means? Here electronegativity of atom A, that means Ja, minus electronegativity of atom B, that is Ja minus Jb equals to 0.208 root over delta AB. This is we have to consider the CGS units. What are the CGS units means? Here Ja minus Jb 0.208 root over delta AB. It can be expressed in terms of kilocalories per gram atom. When we are expressed in terms of SI units, means here Ja minus Jb equals to 1.017 root over delta AB. Root over delta 1017. 0.1017 root over delta AB. Right children? It can be expressed in terms of kilojoule per gram atom. Right children? So this is the scale we have to consider as a Pauling scale. According to Pauling scale, still we have to following the Pauling scale. According to the Pauling scale, the highest electronegativity element is fluorine. The highest electronegativity element is fluorine. Highest electronaffinity element is fluorine. Highest electronegativity element is fluorine. What is the value of electronegativity of fluorine means? That is 4.0. What is it? 4.0. The highest electronegativity element is fluorine. The electronegativity of fluorine is 4.0. Right children? So this is about what is meant by electronegativity. What is the first scale explaining about electronegativity? That is the Pauling scale. Right children? So now we are going to discuss about the second scale, that is the Millikan scale. What's the name? Millikan scale. See here, Millikan, he was taken there are two periodic properties. Those two are already we discussed in the last classes. That is electronegativity of Millikan scale equals to electronegativity of Millikan scale is equals to it is the average of ionization energy and electron affinity. Here electronegativity of Millikan scale equals to it is the average of ionization energy and the electron affinity. That means ionization energy plus electron affinity by 2. Ie plus A by 2. See, this is the statement was given by Millikan. Who is the scientist name? Millikan. This is the scale we have to consider as a Millikan scale. See here, when we are taking out the relation between Pauling scale and Millikan scale. What the relation between Pauling scale and Millikan scale means? Here electronegativity of Millikan scale equals to 2.8 into electronegativity of Pauling scale. That means suppose if we can take the example of electronegativity of fluorine according to Millikan scale. Here, electronegativity of Millikan scale of fluorine 2.8 into 4.0. 2.8 into 4.0. That means here 4 8s are 32. 4 2s are 8 plus 3, 11. So, approximately electronegativity of fluorine according to the Millikan scale, that is the 11.2. But there is no another element having this much of electronegativity. That's why Millikan scale is wrong. Millikan scale is wrong. So till today we are following which is the scale, children? So till today we are following the one of the scale, that is the Pauling scale. Right, children? So this is we have to consider say one of the scale, that is the Millikan scale. Okay, children? Now we are going to discuss about the last scale, that is Avogadro scale. What, children? Avogadro scale. See, children, Avogadro, he was explaining about electronegativity based on the screening effect. Based on the screening effect and the nuclear charge. Already we discussed in the last classes, that is the nuclear charge, children. Once we have to revise that. Right, children? Here last scale, that is Avogadro scale. Avogadro scale. Avogadro scale. Avogadro scale means, suppose if we can take that, means here this is where the nucleus and radius of the atom. See here, when the electrons can be revolved around the nucleus, here some electrons can be acting as a screening effect. Here those electrons we have to consider that for the nuclear charge we have to consider the screening constant values. That means sigma values. Right, children? See here, according to that, here Z effective, here the force of attractions between this molecule we have to consider as a Z effective nuclear charge. Z effective nuclear charge by R square. Z effective nuclear charge by R square. Right, children? Here Z effective nuclear charge is square. Here charge of electron square into Z effective nuclear charge means here. Well, already we know that. How can you find out the Z effective nuclear charge? Here Z star equals to Z minus sigma. Here Z star is the effective nuclear charge and Z is the nuclear atomic number or nuclear charge, sigma is the screening constant values. So we have to find in the Z star values. After these values we have substitute here, then we are getting the electronegativity of Avogadro scale. But till today it is also failed. See here, so Millikan scale is failed to explaining about electronegativity. Avogadro scale also it is failed to explaining about electronegativity. Finally, till today we are following the one of the scale, that is the Pauling scale. According to the Pauling scale, the highest electronegativity element is fluorine. Right, children? So this is about what is meant by electronegativity and what are the scales or explain about electronegativity. Right, children? So in the next class we have to discuss about how the electronegativity will be varied in periods and groups and what are the factors can be affecting on electronegativity. Right, children? So please all of you write these all points in your CW. Okay, children? Thank you very much.